அனைவருக்கும் வணக்கம். இன்னைக்கு நம்ம பார்க்க போற டாபிக் +2 பிசிக்ஸ் யூனிட் 8ல dual nature of radiation and matter. So topic number 8.3.2 de Broglie wavelength. De Broglie wavelength. So the momentum of photon of frequency is nu. So we are taking the photon frequency is nu. So this P is equal to h nu by c, that is equal to h by lambda. So in the equation எப்படி வந்துச்சு, how it will come, that is first equation, Einstein equation is equal to mc square and another equation is equal to h nu. So இந்த ரெண்டு equationையும் ஈட் பண்ணுங்க. So m c square is equal to h nu and m into c that is equal to h nu. We are taking these terms called as P. This Pc is equal to h nu and P is equal to h nu by c. This is our equation. First de Broglie momentum, that is momentum equation, and c equal to, substitute the new value, and c is equal to nu lambda and nu is equal to c by lambda. Substitute this new value in this momentum equation, we can get the P is equal to h by lambda. And in de Broglie, in above equation, general form, that is general form equation, and here particle mass m and traveling with velocity v. Suppose the lambda, that is P is equal to h by lambda, convert the equation, lambda is equal to h by p. The particle having the mass m and velocity is v means this lambda is equal to h by m into v. M into v, that is called h by p, that is momentum equation. So this wavelength called de Broglie wavelength. So lambda is called the de Broglie wavelength. And this equation relate the wave character. So wave character of the particle, and h is the Planck constant. H is the Planck constant. So another de Broglie wavelength of electron. We can calculate the de Broglie wavelength of electron. 8.3.3 de Broglie wavelength of electrons. So let m is the mass of the electron, and electron has accelerated with velocity v. Potential difference with v volt. It is potential difference, and acquiring the kinetic energy is kinetic energy of electron It is 1 by 2 m v square is equal to electron volt. Therefore, speed of the electron. So v square is equal to 2 ev by m, and v is equal to root of 2 ev by m. This is the velocity of the electron. This is the velocity of the electron. The wavelength lambda associated with matter, that is matter waves. So lambda is equal to h by mv. Substitute the v value in this equation, and h divided by m into 2 ev by m into root, and cancel, we can get root m here, and lambda is equal to h divided by root of 2 m e v, 2m ev. Substitute all the values. So lambda is equal to h value 6.626 into 10 minus 34 divided by root of 2 volt into 1.6 into 10 power minus 19, and 9.11 into 10 power minus 31 kilogram, that is mass of the electron. And simplify this value, 12.27 into 10 power minus 10 meter divided by root v, and 10 power minus 10 meter called as Armstrong, that is 12.27 Armstrong divided by root v, root v, and the electron accelerated, that is v, taken as 100 volt, 1000 volt or 100 volt. If we take 1000 means, so root v 10 into 10 into 10, that is 10 root 10. And if we v taken as 100 volt means root 100 taken as 10 volt. So substitute the value, lambda is equal to 12.27 Armstrong divided by root 100, and we can get 12.27 Armstrong divided by 10, that is equal to 1.227 Armstrong wavelength. If kinetic energy, that is K, is equal to electron volt, if we take in, so substitute the value, lambda is equal to h divided by 2 K. This is the de Broglie wavelength associated with electron. Okay, so momentum and wavelength. So wavelength have many other different types of forms. So lambda is equal to h by p, one form, h by p, and h divided by mv and h divided by root 2m ev. These are the different types of form forms of lambda equation. Thank you.